Okay, we are looking at trig values for pi over 6, pi over 4, and pi over 3. These are your special right triangles. So whenever we see any of these, we need to have the special right triangles available so we can use those as a pivot point for answering these. First thing, it's really good to know that the degree equivalent of each one of these. So whatever you do for each of these, going either way, we have a converter that's pi over 180 or 180 over pi. So what this does is it converts it into degrees or radians. Radians, you can always tell because it usually has the pi or it will say radians, and 180 always, or the degree, always has the degree symbol, the little dot at the top right. So if I wanted to convert pi over 6, I would take pi over 6, and I would decide which one of these I would use as a converter. These are also equal to 1. So that's why we can use it as a converter, is I can multiply anything by 1, and it is an equivalent form. So the key is I always make sure that whatever I'm trying to cancel is on the bottom. So there's a pi right here. I need to cancel that pi. So I make sure there's a pi on the bottom, and that would be this one right here. And that would put 180 on top. And we're multiplying these straight across. The pi's cancel. So pi's cancel. That was the whole point. Get rid of your radian pi's. And then 6 goes into 180 30 times. And we're left with that unit of degrees. So pi over 6 is 30 degrees. You would use the same type of converter for pi over 4. That would give you 45 degrees. And pi over 3, remember, if you have a third of a pi, that's more than a sixth of a pi or a fourth of a pi. That's your biggest out of these. That's 60 degrees. So the three angles that we need to have are 30s, 45s, and 60s, or pi over 6, pi over 4, pi over 3. It doesn't really matter which they give us. So we always use right triangles for the special right triangle. So here are the two that have to be memorized or readily available. So I'm going to call this my 45s. So that's 45 and 45. So these are isosceles triangles. When the legs are the same, the angles are the same. And that would be this one right here that we're dealing with first. And I like to remember it as x. If this side is x, this side is x. And then the last one is x radical 2. Okay? Sometimes you can also have this as you can have it equal to 1, 1, and then if x is 1, this would just be equal to radical 2 for the hypotenuse. All right, so that's our first special right triangle. The second special right triangle, I have it memorized in this format, where 60 is on the bottom. Right angle, if 60 is on the bottom, this is a right angle. What's this last one? That would have to be 30. These are complementary, meaning they add up to be 90. And I like degrees, so I always have the degrees memorized, and then I just convert them into radians as needed. So this would be x, 2x, and then the last one, x radical 3. So I remember it as 1, 2, 3, with the last one having a radical. This one I remember as 1, 1, 2, with the last one having a radical. And then I just memorize this form, and then I can rotate it any way we want. So in this case, we have a pi over 6. Pi over 6 matches my 30 degrees. So that means I'm looking at this angle right here. So this one right here is really a 30. That means this one is a 60. All right. So we're looking at sine of pi over 6. And then let's not forget the hypotenuse in this case is 12. That's why it's important to get away from 1, 1 radical 2 or 1, 2 radical 3 on this one, because when you have different numbers, you can set it equivalent to each part here and solve it for x. All right, so in this case, we are looking at sine of pi over 6. So anytime you have a trig function, sine, cosine, tangent, we need so, ka, toa. All right, in this case, we're looking at sine. That's this one right here. So sine is going to be equal to, I'll just rewrite it, sine of pi over 6 is equal to opposite over hypotenuse. Okay, so when we look at this one, we're looking at this angle right here. That makes this the hypotenuse. It's always the hypotenuse. Hypotenuse is always across from the right angle. And then opposite of the angle we're looking at. Opposite the angle we're looking at would be this side right here. This would be your opposite side. And then adjacent would be this one right here. Adjacent means next to. We're not worried about adjacent, so a lot of times I'll just cross that out to help me focus on this one, and in this case, hypotenuse. All right, so now the next trick is we take what they give us. In this case, they give us a 12 as the hypotenuse, and I need to find the opposite side for this using the special right triangle. So the trick is we compare it to either one of these. Which one would we do? We would do this one down here, because this is the 30, 60, 90, matching this one. We have 30, which would be this side right here. So this is the side we're focusing on. Sorry, angle. This is the angle we're focusing on. And then that means, where does the 12 match? What does the 12 match on our shape here? Okay, so 12 is the hypotenuse. That means it matches this one right here. So I set this generalized form equal to what it's giving us in this problem. So it's equal to 12 right here. Okay, and then my goal is to find the opposite side. I don't have to worry about the between 30 and 90. I look at the side that's between 90 and 60. So that's kind of the key, is I look at the degrees and the right angle to let me know what side I'm looking at. So that means I'm looking at between 90 and 60 is this side right here. So I need to solve for x. Whatever I get for x, I'll plug it in. So divide by 2, divide by 2, and I get x equals 6. That means this x is x equals 6. I now have all the information I need to get through this problem. So this side right here, the opposite side, is equal to 6. And then I could fill in the adjacent side if I wanted to. That would be also a 6, just as a note. Sometimes they ask for that. So that would be 6 radical 3. Okay, but like I said, we're not worried about that one. Opposite over hypotenuse. Almost done here. The opposite side is 6. The hypotenuse is 12. And then don't forget to always reduce. That reduces to 1/2. So that's going to be my answer, 1/2. And it's really important to kind of note on these. It's saying exact value or round to the nearest hundredth. Better to focus on the exact value. We can always type it in a calculator to find out what the nearest hundredth is. But answer is 1 divided by 2. So the trick is, when doing these, is have your special right triangles available and ready. Write out the generalized forms of them. Make sure you link together whichever one that they're giving you the problem for. And use the pieces they gave you to fill in any of the other missing pieces. Okay? Once you solve for x, you'll be filling that in. Then, of course, as always, SOHCAHTOA helps make sure that we get the right ratio or fraction for these. Pi over 6 again, so that'd be exactly the same thing. Tangent of pi over 6, so all the steps would be followed in the same way.